Hello, welcome to video 6, acceleration time graphs. Let's just quickly recap what acceleration is, and we've mentioned this before. It's the rate at which an object changes its velocity. And we can have another term which we sometimes use is deceleration, and that's a negative acceleration or slowing down. And we'll get a better grip of what negative acceleration means when we do the equations of motion. But right now, we just need to recognize that acceleration is the rate at which the velocity changes. And we've got all these formulas here that we've used before, but how does that relate to motion graphs? So, if on a acceleration time graph, we display the motion of the object with, again, as always, time on the horizontal axis, but we have acceleration on the vertical axis. And they look a little bit different from some of the other graphs that we've been drawing. Now, to get an acceleration time graph, we actually have to start off with a displacement time graph or a velocity time graph. And usually you're given a velocity time graph like this one here, where we have meters per second and we have a time of 40 seconds. So how would you interpret this? Hopefully you're already at the stage where you'll be able to read off some things about this, but what would the acceleration time graph look like? Perhaps have a think about it for a second, pause it for a second, and then get ready for the next slide to come up where I'll work you through it. So maybe pause now. Did you pause? Okay. Right. Remembering that on a velocity time graph, the slope gives us the acceleration, and so we'll need to analyze and do some calculations so that we can sketch the acceleration time graph for this velocity time graph. So the first thing that we do is we do the rise over run and we work out the slope here. So we've got 10 and we've got 20, so that's going to be 2 meters per second per second. That's the acceleration. This flat line here, 0 acceleration. And you can guess here that this is going to be a negative acceleration. Hopefully we've got the idea that if you're climbing up a hill, it's positive slope. If you're going down the hill, it's a negative slope. Doesn't matter where you are relative to these axes, it's the same everywhere. And so we would work out, excuse me, just recovering from a bit of a cold. So I'm a bit croaky and you might hear it. But here, instead of here we did rise over run, here we'll do fall over run, which is a little bit different. We start up here, we go down, and because it's down, it's going to be minus 20 meters per second, and here we've got our 20 seconds. So the slope here is minus 1 meters per second, and that means that the velocity is decreasing every second by 1 meter per second. Make sense? I'll say that again. So a minus 1 acceleration, or minus 1 meters per second acceleration, means that the velocity is changing by minus 1 every second. So you could be doing 12 meters per second, and then a second later, if you're decelerating at this rate, a second later you're doing 11 meters per second, and then a second later, 10. Get the idea? So now these numbers here, the 2, the 0 and the minus 1, we need to put onto our time axis and have acceleration as our axis to draw our graph. And this is what it looks like. Now notice here that it's very chunky. That's because if we go back, let's see if that works, our transitions from acceleration to no acceleration are instantaneous. Now in the real world it wouldn't be like this. But for physical science, we make it a little bit simpler. And here's our negative. And it just looks like that. Now, we can't interpret anything else from this graph. This is purely showing us the changes in acceleration with time. Some states make you work out the area under this, because the area under this would represent the change in velocity over that period, but we won't make you do that. The only thing we'll ask you to do is to sketch the acceleration time graph. Alright? Fortunately, that's the end of this video because I'm just about to lose my voice. In the next video, which I've already made, you'll be able to look at motion graphs and displacement time examples, and I'll talk you through quite a few of those, and hopefully by the end of that you'll have a good idea of what you're doing. So, cheerio!